Hey friends, this is Jim here with Science Talk. I want to share with you two studies that have been recently published, and they deal with what the warming oceans is doing to organisms in the sea. Namely, it's driving them north, right? Oceanic heat waves, if you will, driving the fish north. So as the seawater is warming, subtropical fish are moving north, and temperate water fish are moving north. So what happens to organisms in the polar regions? They're kind of running out of space. So in the first study that I want to share with you, it appears in the journal Scientific Reports. And researchers in California can now identify 37 species that have shifted their range further north. So there is a general northward movement of flora and fauna as the temperatures increase. This is true for aquatic ecosystems as for terrestrial ecosystems. We see this in Alaska, for example, where it used to be, say, tundra vegetation. We're now seeing willow shrubs, as an example, because the permafrost is thawing, allowing for deeper roots to take hold, and willow shrubs prefer deeper roots. Tundra vegetation only need a shallow root. They take hold, and the temperatures are increasing, which they like, and so they're pushing forth, and of course the animals follow that. So we're seeing now, and now it's being documented as well in the open ocean. So let's go through some examples here. In the years 2014-2016, the pelagic red crab, Pleuroncodes planipes, was spotted off Agate Beach, Oregon, a full 595 kilometers further north than ever before. Now you can say, well, that's just a one-off. That would be a valid criticism. A deep water invertebrate called the black-tipped spiny dorid, Acanthodorus rhodoceros, also made it to Oregon, 620 kilometers from what had previously been its most northerly range. Both were joined by an assortment of snails, sea butterflies, pteropods, nudibranchs, red algae, sea anemones, siphonophores, fish, dolphins, sea turtles, other citizens, if you call them that, of the subtropical seas are moving north to what had once been cooler waters, too cool for their liking, but now it's warmed up enough that they can tolerate it. I remember on a research cruise in Prince William Sound, we're out there with our plankton nets and our CTDs, conductivity, temperature, depth. It's a way to measure the profile, vertical profile of the ocean in terms of temperature and salinity, and then you calculate the density from that over depth. And we're out there looking and going, well, look at that. And lo and behold, there was a hawksbill turtle flapping around in Prince William Sound. And I will admit, the kind of sign had a look of like, where the hell am I? But there he was. Or she, we don't know. But there's a hawksbill. We don't get hawksbill in Prince William Sound, but there it was. So these researchers, led by Eric Sanford, who is an ecologist, University of California, Davis, what they did was they collected their data in the wake of two significant changes in water temperatures. There was the so-called mysterious blob of warm water that made the journey south from the Gulf of Alaska. We really don't know what the hell that's about. The other was a blister of warm water moving northward. That was a result of El Nino, and the El Nino of 2015. So they recorded 67 rare warm water sightings off California, Oregon. Of these, 37 had never been observed so far north. So Dr. Sanford states, against the backdrop of climate change, we hope southern species will track northward because that's necessary for their persistence and survival. It's perhaps a glimpse of what Northern California's coast might look like in the future as ocean temperatures continue to warm. Okay. The second study I wish to share with you, published in the journal Nature Climate Change. Not only were the oceans in 2018 hotter than any time since records began, and I've shared that data with you several times, but periods of extreme heat on the high seas, marine heat waves, if you will, are also on the increase worldwide. Between 1987 and 2016, make sure I'm reading that right, yeah, 2016, the number of heat wave days per year was 54% higher than for the years 1925 to 1954. This is not just true for the Eastern Pacific, but for many regions of the Atlantic and Indian Oceans as well. So this is not going to be good news for individual species, not going to be good news for ecosystems. It's not going to be good news for key species, be it kelp, coral, seagrasses, etc. These groups of organisms provide habitats. Seagrass beds, for juvenile fish. That's kind of a nursery for them, as an example. Of course, you got the kelp forest. We have sea otters like to hang out in there and go fish for abalone and hang out. So, what constitutes a marine heat wave? Well, the researchers define marine heat waves as episodes in which sea surface temperatures exceed the seasonal norm for at least 5 consecutive days. It's not just a blip, we're talking about 5 straight days at least, almost a week. Increasing heat waves over land have already been identified as potentially a threat to not just human life, but most terrestrial organisms. And so, as can be expected, marine organisms will also be affected. Now, when you have organisms living in the open ocean, they tend to be stenothermal. Thermal referring to temperature. Steno means a narrow range. So these organisms prefer a narrow range of temperatures in which they will do well in. Compare that to a eurythermal organism, which can tolerate a wide range of temperatures. Well, eurythermal organisms will be found in coastal areas, estuarine areas. Same thing for euryhaline organisms that can tolerate a wide range of salinity. These organisms are found in estuaries, coastal regions where there's mixing of fresh water with the brackish water and the marine water. Stenohaline organisms are organisms found in the open ocean where they tolerate just a narrow salinity range. Well, there's also stenothermal, and they tend to be together. Most organisms are stenothermal and stenohaline in the open ocean. And if there's euryhaline, they tend to be also eurythermal. What this means is that you start warming the temperatures, and they're now getting out of their comfort zone. This is why they're fleeing north. It's too warm for them. They're stenothermal. They can't tolerate that. So they're going to move north to cooler waters, which is this is better. We like this. That's basically what's happening here. So Dan Smale of the UK Marine Biological Association, who led the second study, the one that appeared in the journal Nature Climate Change, he states, ocean ecosystems currently face a number of threats, including overfishing, acidification, plastic pollution. I've talked about that on occasion. But periods of extreme temperatures can cause rapid and profound ecological changes, leading to loss of habitat, local extinctions, reduced fisheries catches, and altered food webs. The major concern is that the oceans have warmed significantly as a result of what humans have been doing, so that marine heat waves become more frequent and will likely intensify over the coming decades. Just as atmospheric heat waves can destroy crops, forests, and animal populations, marine heat waves can devastate ocean ecosystems. And when you throw in the concept of specific heat, that's even more devastating. So there you have it. Well, the oceans are warming up. Organisms are moving northward to get to temperatures that more to their liking. But the ramifications for what it's going to do to the ecosystems, the fisheries, etc., is profound. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.